So we're talking about rational functions. This is what you've been working on with section 8.1 and 8.2. Now we're just going to continue on and build off of it. 8.3, yes. Continuous graphs. So you see these definitions. This is going to be pretty important for you guys. So we got a continuous graph, a graph with no jumps, breaks, or holes. If you have no idea what I'm talking about, you will after this lesson ends. A discontinuous graph is a graph with a jump, break, or a hole. Point of discontinuity, I'll show you that too. So when you are looking for point of discontinuity, you're looking at the bottom piece, so the denominator. That's what we want to focus on to find our point of discontinuity. There we go. So the bottom, or your denominator, that's what we're focusing on. So x minus 3, hopefully everybody knows that you can never have 0 on bottom in a denominator. Since x minus 3, if we set that equal to 0, because that's what we don't want it to equal, and you solve, you get x equals 3. So let's check that. 3 minus 3, does that give us 0? Yes, it does. So that is physically impossible for you to have this 3 as an answer. So that's your point of discontinuity. Okay. Then we have a removable discontinuity. Again, I'm going to tell you what all of those mean. But again, you're looking at your bottom and your top with this piece, and it's what can you eliminate, okay? So if you have no idea what's happening, just pay attention during the lesson. Okay. Oh, and then we have a non-removable. So take some time, read it, and we'll talk about it as we continue on. So we're in example 1, okay? And it wants us to graph, but we also want to find our discontinuities. So this is a really basic graph here. If you got onto Desmos and you graphed, you would be able to see what the graph actually looks like, or you could get a graphing calculator. Makes me no difference. Whatever works for you. So let's get this part going here. So I just took a screenshot of my screen so I can write on it. So that's what's happened. So I told you, if we are looking for information, we're looking at what's going on at the bottom right here. Okay, so we have x squared. Well, I told you guys you can never have 0 on bottom. So if you have, hopefully you guys could tell, but x squared equals 0. You set whatever on bottom equal to 0 and you solve. Well, the square root is how you get rid of a power of 2. What's the square root of 0? Hopefully everybody's saying 0, right? X equals 0. So technically, instead of saying x equals 0, we have to say x cannot equal 0. That's where our discontinuity lies, is that line. X cannot be 0. Well, hopefully you guys know where that line is. It's the y-axis here. So this is where x is 0. So if you graph this, you're going to be able to tell that there's an asymptote right here. Okay, so I recommend getting onto Desmos and graphing this particular graph. I'm not going to fill it in up here because it's going to be easy, hopefully for you guys to see. If you couldn't use Desmos, you could plot your points, pick any x's you want, plug them in, and you'll get your y's. Okay. Let's do example 2. Okay, so it looks like a lot of information going on here. We have x plus 2, x minus 2, and then on bottom, x minus 2 here. What is something that you notice about example 2? What do you see? 2 of the same pieces, right? Does everybody see how x minus 2 and x minus 2, they're the exact same thing? That means that these guys in our math world, they cancel, right? right? Anything divided by itself is always 1. So when something cancels, that's when it's the removable. All right. Now, instead of removable, I'm going to use the word whole because you're going to see that. What's the whole in this graph? Anytime you remove something, that's a hole in our graph. A hole is a point. Okay. So we have x minus 2. That's our hole, but you still have to set it equal to 0. So if we solve this, x equals 2. Okay, so on our graph, if you graph this on Desmos, you're not going to find the hole at all. I'm 100% sure you're not going to find the hole. But wherever x is, when it comes to 2, that's where your hole's going to lie. And I'm going to show you what it looks like on this graph. Okay, so we have x equaling 2. That's where our hole is. We have no, your asymptote does not exist, the one that we talked about in example 1, because you removed it right here. Okay, so now the equation that we have left over is y equals x plus 1. Well, this is just a linear equation. You start at 1, right? Go up 1, right 1, up 1, right 1, or down 1, left 1. So that's at 1. Here's my 2, right? Up 1. This is where my hole lies. That's what this means. When we talk about a removable or a hole, it's not, that means that this answer is never going to be possible in this graph. So it's like a line and then bam, somebody punched a hole in it. Okay. The last one here, we can't remove anything. All right, but what we can do is set the bottom piece equal to 0. So x minus 2 equals 0. So x cannot equal what number? 2, right? Therefore, in this graph, where x is 2, you have an asymptote. This is your asymptote. So if you plug this in on Desmos, I recommend doing so you can see where the graph is. What you know right now without graphing it at all is that you have an asymptote at 2. Okay. Okay, so we talked about vertical asymptotes. How you find your vertical asymptote is going to be at the bottom of your fraction. The horizontal asymptote is going to be this little box right here. This little box right here, this is going to be your friend when finding the horizontal asymptote, okay? So vertical asymptote is the bottom denominator. You set it equal to 0 and solve. Horizontal asymptote, these are your rules, okay? So when n is less than d, what they mean by n and d, this one is the numerator degree versus the denominator degree. So let's look at example 4 here. The highest degree on top is 1. The highest degree on bottom is 1. They both equal each other, correct? So when n equals d, you take the leading coefficients. So in this example, what is -8 divided by 2? -4. So that is your horizontal asymptote, okay? When n is larger than d, if you look at c, does everybody see there's a power of 2? And this is a power of 1. Our numerator is larger then our denominator, because you're looking at the degree, anytime the top degree is larger, it's no horizontal asymptote. So if you need to rewrite this and say top versus bottom, okay, I don't care. Make a little note, but that's what this means. N is the highest power on your numerator. D is the highest power in your denominator. Okay. Let's look at part B. Here you see that N, it's a 1, and D is a 2. So since the larger number is on bottom, it's y equals 0. These are the 3 rules with your horizontal asymptote. Please make note of that. Okay, so we just found all the horizontal asymptotes by looking here, but we're going to go a step further, just one step further. We're going to find the vertical, horizontal asymptote, and if there's a hole, because those are the 3 things they're going to ask in a graph. Okay, we're going to do example B here. We've already established that our horizontal asymptote, is y equals 0. Well, how I knew that was by looking at this table. It's our friend. So this is my horizontal asymptote, HA. Our vertical asymptote, we have to look here. But first, you guys have to think back on factoring, which was y'all's friend. I know you loved it. We have on bottom, it's going to be x plus 2, x plus 2. So for those of you that cheated your way through factoring, guess what? You're going to have to figure it out now. Okay, nothing cancels. So hopefully you're saying, okay, well, there are no holes because nothing canceled. And now on bottom here, I see 2 pieces. I have an x plus 2 and an x plus 2. You seriously have to set that equal to 0. Both pieces and solve. So x equals -2 and x equals -2. Okay, so my vertical asymptote, I don't have to write it twice since it's the exact same answer. My vertical asymptote is x equaling -2. So my horizontal asymptote, vertical asymptote, and none. That's there's no holes. Okay, let's do part C. On the top, we have to factor. So we're going to have an x plus 3 on top, and then an x minus 1 all over x minus 2. So I'm going to ask myself, does anything cancel? Hopefully you're saying no, nothing cancels, so therefore there's no holes. None. Vertical asymptote, that's my bottom. Well, x minus 2 equals 0. When you solve, x equals 2. Okay, that's my bottom. And then here I have to come back up and look. Okay, what do I have? I have a 2 on top. 2 is larger. Therefore, I have no horizontal asymptotes. So, horizontal asymptotes, none. Hopefully that kind of gives you a quick description on how to do this. Please feel free to text me or send me an email if you still need help.